Hello and welcome back. Today we will be analyzing text using regular expressions with grep. So grep is an application that will print lines matching a pattern. So I'm just going to copy over this configuration file to the working directory. Okay, I'm going to rename it as the main file. Okay, let's take a look at it. It has a lot of comments, blank lines, and configurations here, and that's typical. The test file is the personnel file that I will use. Very interesting. I'm going to clear the screen, and let's talk about the dot character. The dot character will match anything. So let's take a look at this. I'm echoing Oregon, and then I'm using the grep to match on org and then any character that comes after org. So you see it has matched A here. However, if I wanted to match a literal dot, I would have to use the / character right in front of it to escape that character, so that I could look for a literal.org in both of these files. Okay, it has done so. Now let me up arrow and then remove that escape character, and now I am specifying that I want to find anything before any character that comes before org. So it matches on space org and then .org. So grep is great at finding a specific pattern in a large amount of text, and it uses regular expressions that are defined as a sequential arrangement of characters that define a search pattern. So take a look at the syntax here. You have one or more options, and then you have the pattern, and then you'll have the file that you are, or files that you are looking through. And it can also take arguments from standard input. So you can echo into it, or you could refer to a file if you would like. So I'm going to create this subdirectory to the temp directory, and I'm going to echo hello to a file in that subdirectory. I'm going to use this option. The recursive option will read all files under each directory recursively. So I want to look for this pattern recursively through the temp directory. I want to use 2 greater than to, and that will stand for standard error. So I'm sending standard error to the dev null device. This device will destroy any data that is sent to it. I'm just saying I don't want to see the error messages here. So it has found the pattern, but it will not follow symbolic links if they are not on the command line. Let me demonstrate what that is. I'm going to use T that will read from standard input and then write to standard output in files. And that is a very useful command if I want to echo a string into a configuration file at the etc directory. So I'm echoing hello, and then I'm piping that to T, which is running as root. It will append this information to the etc hello file, and then send the standard output to dev null so that we do not see it on the command line. And let's take a look at this file. So we've added our string to the file. I'm going to create a symbolic link in the working directory that will refer to the etc hello file. Okay. So now I'm going to use the recursive option on home tux to look for this pattern. I'm not exactly finding what I'm looking for. Okay, I'm just going to quit, and then I'm going to look for this in the etc directory, and I find my pattern because the recursive option will not automatically follow the symbolic links, but I do know an option that will. I'm going to clear the screen, and then I'm going to echo the string there to file 4 in the working directory here, and I'm going to create a symbolic link in the temp subdirectory that points to file 4 in the Tux user's home directory. Okay, so now I'm going to use the deference recursive option to look in the temp directory for this pattern, and it finds it because it will follow all symbolic links. And I wanted to point that out, the contrast between these two very powerful options. Imagine if your pattern was so large you would want to put that in a file, so you would not have to type it every time on the command line. So this is possible. I'm going to add this pattern all to all file, and then I'm going to use the file option to specify that all file is my pattern, and the all pattern will match a standalone word or a constituent of another word. Very valuable option to remember. Another one is the regexp option, and that allows me to search for multiple patterns with the same command, so I could have a whole list of configurations that I wanted to take a look at in this file. Very useful. I use this very, very often. Sometimes when I'm looking for something, I don't know whether one character or any of the characters are capitalized, and sometimes I miss things because of this, so I can use the ignore case option to display both uppercase and lowercase characters. Okay, and very, very useful option. So the last log command reports the most recent login of all users. So let me take a look at that, and you can see that the services have never logged in, but the users have. So I want you to know that, I want to point out actually that all of these error messages are worded exactly the same way. Okay, so now let's use the invert match option to specify that I want to see every line that does not match this pattern. So the header is matched, and then the 2 lines with the users is matched. So very, very powerful if you want to cut out a lot of, in particular, error messages. So the caret represents the beginning of the line. It's called an anchor. And then the other anchor, the $, represents the end of the line. So here we have anything beginning with Q or anything ending with postfix. Okay, so if I were to, I've done this before, look for the pattern all in the main file, then it would find word constituents and it would find standalone words. So the \, symbol matches the empty string at the beginning of the word, and the \, symbol matches the empty string at the end of the word. So this is looking for the empty strings on either side of all. Therefore, it will match these standalone words. Another option that does a similar job is the word regexp option, and this works similarly, but it has a different test. So the test is that the matching substring must either be at the beginning of the line or preceded by a non-word constituent character, and then similarly it must be either at the end of the line or followed by a non-word constituent character. So word constituent characters are letters, digits, and the underscore. I wanted to point that out because the way that these I'm going to clear the screen. The way that these methods match characters is very different. So let me paste this. So I have made this word a standalone word by putting empty space at the very beginning and the very end of it. Okay, so see how it works. So now I'm going to use this symbolage to try to find hot and as a standalone word here. So it does not match it. However, the same thing here, I'm using the word reg exp option, and it is matched. And I found this very fascinating, these facts very fascinating when I investigated this. So if I were to and then hold on, let me just copy and paste this. So I'm going to replace these letters with word constituent characters, and it will find it. But so the lesson here is that the this symbolage will only match on word constituent characters. It will only find match if it contains word constituent characters in its entirety. Let's try that. Let me just add something to it. See, it won't match that character. So that was the lesson I wanted to teach, and it might be a valuable lesson going forward. Okay, let's move on. Okay, so my next point is when we write the pattern, we always enclose it in single quotes so that their literal values are preserved. So I'm going to look for a phrase here, and it would not be possible if I did not enclose this in single quotes. Yeah, it would find a lot of junk. So let me just clear the screen. And if I wanted to look for something specifically, I could use the caret anchor to specify the beginning of the line, and then the $ anchor at the other end to specify the end of the line, and then whatever I wanted to be specified exactly in between these characters. And I could also use the line reg exp option because that option will select only the matches that exactly match the whole line. Now, sometimes you will want to count the matches that you find. So there are 11 matches here, and that's the count option. I'm using this for the last log commands so that I can see how many services have ever logged in, and then how many users that we have that have logged in. Now let me remove the count option, and I just want to highlight again that this counts the header. So we only have 2 users here. Okay, so moving on to another set of options. I'm going to echo 1 to file 1, echo 2 to file 2, and then I'm going to use files without match here to look for the pattern in these files. And the same thing with files with matches. It finds the files with matches rather than the files without the match. So very powerful if you are looking through a lot of files for the matches that you're looking for. If you only wanted to see 2 matches, you would use the max count option. The only matching option will only show the pattern that is matched rather than the entire line. As you can see here, the entire line is matched by default. Now imagine you were debugging a file and someone wanted to know on what line numbers are all of the errors. The line number option will display the line numbers that the matches are found on. Okay, let's move on to the next one. We're going to echo 1 to file 3 that has a .txt suffix, and let's just look through all of the files, and we're finding our matches. Now the exclude option is like a blacklist in that it will prohibit something but everything else is allowed. The include option acts as a whitelist because it excludes something, actually it includes something, and then everything else is excluded. So let me show you how that works. I'm going to exclude the .txt, any file that has the .txt file, suffix at the end. And you see it only pulls from file 1 and file 2 and not file 3.txt. So we have excluded this, but we have allowed everything else. So this command will include the .txt file, but everything else will be prohibited. So file 3.txt is included, but everything else is excluded. So it's a bit like an access control list, actually, and very useful if you want to exclude some files from your matches. So I'm going to echo 1 to this file. This is interesting here. I'm going to show you this now. I've been dying to watch. I'm going to create dash file. And so this file name has a dash in front of it. You're never not supposed to do this. It's very not recommended to do this, because when you try to list it, you can't list it. When you try to remove it, you can't remove it. You can't even grep it. But here we see a clue, ILE, no such file or directory. So it thinks that this is the file argument, and it thinks that this is the command argument. It thinks that this -f is a command argument. So let me just up arrow key, put 2 dashes here, look, put a space, Okay, so this tells the machine that beyond this point, command options are not going to be there, and only positional parameters will be accepted beyond that point. So it no longer takes -f as an option, and instead treats dash file as a file name. And you see the grep command has executed correctly. And now the remove, well, let's just list it first. The remove command will work. Very, very interesting, something I'd memorized. I'm going to clear the screen here, and I'm going to echo. So for your information, if I am using one greater than symbol, then you can use that standard input symbol to write to a file, but it will overwrite the file, or it could also create files. I use this quite a lot, but I'm going to use 2 greater than symbols because I only want to add this string to this file. Actually, these 2 strings, because I'm using the E option to allow me to use \n as the new line character. Actually, let me show you how that works. Okay, so hello world, and then hello misspelled world. Okay, and now I'm going to use this symbolage here, and so the dot character means any single character, and then the asterisk means 0 or more characters. So I'm looking for 0 or more of any character that comes after hello. I don't have lab file anymore, but you can see where I have here is anything after world is matched. So that means 0 or more, the asterisk. I'm going to clear the screen and then move on to fun with anchors. Now, let me just do RPM and then query. It would help if I put 2 dashes. Okay, info, and then for the words package, that is a dictionary. Okay, I'm going to clear the screen, and then I'm going to run this command here. And let's take a look. It will start with these letters, end with these letters, and then I'm using the dot symbol in between to represent the letters that I don't know. And this finds its match because I have used the ignore case option to specify that I don't know what is capitalized and what is not. And so the first letter was capitalized. Now here's another example. I don't know the actual spelling of autocorrelation. I don't know how many L's are in this word, so I've used this regular expression to find the spelling. It has 2 R's. So I just looking for blute. So I'm looking. I just wanted to include these labs because anchors are very important. Now I'm going to run this command, and when we use the pipe character, it's escaped by the backslash. The pipe character in between of the pattern, we are specifying this pattern or this pattern should be matched, and it matches actually both patterns here. So the extended regular expression option allows us to use the pipe character without the escape character. But I will elaborate on that in a little bit, actually. Let us take a look at this one. So the bracket expression allows me to use the hyphen character to specify a range of characters. So I'm looking for anything between 1 and 4 as my pattern. Let's work with this a little bit more. The bracket expression specifies a colon, and then I'm looking for groups of 1 colon. So 1 and then 1, 1. So if I increase this to 2, we only find groups of 2 colons. And there is the loopback address for IP version 6. Okay, I'm going to create a file. Then I'm going to clear here. Okay, let's take a look at repetition here. I'm going to just grep the exclamation point so that you can see how I've structured this. Now I'm going to run this command. The repetition is set to 1. So groups of 1. Now groups of characters actually. So 2, 2, 4. Here I'm using 3. I'm setting the repetition to 3. So 3 and 3. Okay, so from the man page, the preceding item is matched only n times. So matched 3 times, matched 2 times. I'm pretty much 2 instances of 2 times. Okay. Now let's move on to this. So the preceding item is matched at least n times, but not more than m times. So at least 2 times, but not more than 3 times. Okay, let's move on to the next concept here. And you could use this symbolage to represent the space, but honestly, I like to use the backslash lowercase s. That works in exactly the same way. Or I could just use just spaces. But the backslash uppercase s, let me clear the screen. This means not. So when a caret is used within a bracket expression, it means not. So just be aware that when and not in a bracket expression, the caret means the beginning of the line. But when the caret is in a bracket expression, it means not. So not space. So I'm looking for soft and then anything that is not space. Well, a character that is not space. So I'm finding the W here. You could also use the backslash uppercase S to symbolize not space, and it will do exactly the same thing. I wanted to include this command because it really illustrates what grep really does for us. So I'm going to clear the screen, and this will do a long listing and then a recursive listing on the etc directory. What this does the entire directory will be unpacked along with the subdirectories and files. So this will be a very large, let me show you if you haven't seen this already, very large output. You see a lot of directories and a lot of files here. So I'm going to quit out of this, and I'm going to grep for SSH in this output. Okay, you see what that does? It pares down that output to something more manageable. It also shows us exactly what we want to see. So I'm going to use tree on this now. And so what is tree? It shows directories in a tree-like format. Okay, I'm going to clear the screen again, and I'm going to move on to a find command. I want to just show how a find command can execute a grep command. So the find command will look in home tux for something with underscore file in the name and a regular file. It will execute a grep command with this as the pattern. And I will go into greater detail regarding the find command in a later tutorial. I'm just going to clear the screen for now. Okay, now the context option is very interesting because I'm specifying one line of context per match. So this will use one line of context to separate the individual matches, or groups of matches actually. So you see they're separated by these separators here. I find this fascinating actually. I'm going to clear the screen again. Okay, and I'm going to look for tux in the etc password file. This file is used by the system to store password statistics, or actually password information. So I'm going to use the with file name option, and that will display the file name that we are working with. I could add the line number option to this to display the line number on which the tux pattern appears. So this might aid you when you are writing a report and you need to add all of this information. You need to echo it to a file or something, or send it to a file. So here's something that's fascinating. When we look, the PS command will report a snapshot of the current processes. So there we have it. And we could scroll through that, but I will quit. And I'm looking for something related to the cron daemon. Okay. And it finds this, but it also finds the process that had to do with grep to find this in the first place. So let's just use a small bracket expression that just specifies that this will start with C and then end with Ron, and that cuts out the cron pattern that was its own word, a standalone word. But if I wanted to find the standalone word, I would use the word reg exp option. Okay, I'm going to clear the screen, and then I'm going to move on to the next thing here. And this is grouping So here I have a group of two patterns with the or symbol in the middle of them. So this matches empty lines, and this matches anything occurring between the two anchors. So I'm finding one, and then the new line, I mean the line that the empty line that I've put between these two numbers, and then 3. So this matches wrong. This matches empty lines. So that's the empty line, and this matches just any character between the anchors. I could use this invert match and just specify empty lines, so anything that is not an empty line will be displayed. Now, spaces or blank spaces are really hard to find. So if I were to use this echo command, you could see that you can't see the actual space that I've created here before the new line. So this is Scott's space. So I'm going to match on basically just one space. There's not, you can't see it, but it is there. So I just wanted to teach you how to match white space if you need to do so. Here's another trick. I'll just clear the screen again, and let's echo hello to file 6. Now we're using the dash character to search in both standard input and files. Did I do that? Okay. So I am catting main file into grep, and the pattern is hello, but I'm also looking in file 6. Now there are multiple ways to do this. You could echo into hello. I mean, you could echo into grep. So I'm echoing hello, and then I'm looking for this pattern as well. But you could also search for multiple files by just putting a space between them and just listing them at the end of the command. So it depends on what you want to do, but perhaps you are echoing in to your grep command and you also want to read from a file as well. So just remember that's the dash at the end. And let me show you what that would look like if you didn't put the dash there. You're thinking maybe I'll just see. It's not going to work. It's only going to read from standard input. So just remember, put that dash in there. I'm just going to clear the screen. Regular expressions search for patterns on a single line, but not for patterns that start on one line and end on another. Before the shell passes the arguments to the program, shell meta characters are expanded. Special characters in a regular expression must be quoted when passed as an option from the shell to prevent this expansion. So I will show you how that works very soon. So more fun with anchors. So here I'm using the asterisk as a modifier. So it specifies 0 or more zeros coming before it. And so it matches on 0, 0. And this command matches R and then 0 or more E's. So it matches R and then REE. So here I am just messing around with matching spaces. So you could use the space bar to match a space, or you could use the space symbolage, I guess, and you could also use the backslash lowercase s It depends upon what your preference is. So the dot character will match any character that comes before it. So I'm matching on anything that comes before at. So fat, cat, and eat. Now here I am specifying the dot character as the pattern, so that will match all of the characters here. If I want to use a literal dot, if I want to match a literal dot, I will have to use the backslash to escape that character. Okay, so here I'm saying anything that comes before the literal dot will be matched. Okay, so this will look for, at the beginning of the line, something that starts with capital T. Then the next character will be from A through Z. The next character will be a vowel, and then the next character will be a space. So there we have it. So you can mix and match these to find the pattern that you're looking for. Again, if you're using the caret symbol in a bracket expression, that means not. So I'm looking for a character that is between 0 and 9 and then not a dash. So I'm looking for something here that is not a vowel. Okay, let me talk about repetition. Okay, so here we have the alphabet, and now we are looking for a so we're looking for repetition. So we're looking for a group of these characters that is not more than 4 characters, actually at least 4 characters, but not more than 8 characters. So groups of 4 or groups of 8 are allowed. Interestingly, if we remove the second number and leave the comma, we are specifying 4 or more characters. So let me use an example for this. I am this \w means the word constituent character. So I'm matching on a group of word constituent characters that is 4 or more characters long. Okay. That could be useful at some point. So now I'm looking for a group of characters that is exactly 4 characters long. So this can have 1, 2, 3 groups of 4 characters. I just wanted to illustrate that a little bit better way here. I'm doing the same thing here, but I have 5 letters in the middle of this string, and so this will match on these 4 characters, but not this last character here. And of course, if you do not escape these characters with backslashes, then it will find the literal string here. Okay, I'm going to move on to back references. It's very fascinating. Let me paste this to the board. And the back reference n, where n is a single digit, matches the substring previously matched by the nth parenthesized sub-expression of the regular expression. And so these parentheses indicate that that the characters are in a group. So in a group, if the group does not participate in the match, the back reference makes the whole match fail. And long story short, we need to find a way of remembering a pattern that we found, and then we need to find out if the same pattern occurred again. So I could just use grep and then look for A, and then B will not be matched. I might use reg exp to help myself out a little bit and then match both of them, I suppose. But the back reference will do a good job here. So what I'm doing is I am matching on A, and then I'm making A into its own group, and then this bracket expression specifies a character between A and Z, so it will match B. And then this back reference will replay the match, so I will look for A again. Here's another example. It's the same thing except for I put B here in the bracket expression. Here's another more detailed back reference lab here. Now I want to match radar in its entirety, so I'm matching R, and then I'm matching A, and then I'm matching D, and then I'm using the to back reference to refer to the second group here, and then I'm using the one back reference to make reference to the first group here. So it matches radar, and that's a fun lab that teaches you how back references work. I'm going to clear the screen here. If you're not using the extended reg exp option, you need to escape all of these characters if you're using them with the backslash, just to gives you some information. Actually, this lab stands alone because I'm using it to illustrate that this is the way that you match a line that starts with a space. So I'm going to use \s to represent the space. And I'm just going to press space, and I'm going to use the asterisk character to say 0 or more, and it will find it. So just for your information, it's a good thing to remember. So the plus character means 1 or more. So I'm looking for 1 or more E. Okay, and here I'm looking for A and then 1 or more E. So EA. Now the question mark character represents 0 or 1. So I'm saying 0 or 1 A and then 1 or more E. Okay. And of course here, take a look at this. So you need to use the backslash to escape these characters so that you can use their superpowers. But if you were to remove the backslashes, it would match on literal E plus A. Let's see what happens if we remove the quotes from it. See, it will not work without quotes. So always remember to quote your patterns, even if you're not using special characters or anything. I like to make it a habit so that this will always work for me. So I'm going to clear the screen. So once more, the question mark means 0 or 1. The asterisk means 0 or more, and the plus symbol means 1 or more. Just going to move on to some grouping. Okay, so I am looking for a group here and at the beginning of the line, and I'm looking for this pattern or this pattern followed by a colon. Let me try this in a different way. I'll just use grep with the extended regular expressions option. So grouping is very powerful. It allows multiple characters to be part of the same unit in this way. So let me, I'm looking for either the that begins with lowercase or the that begins with uppercase. And so I can do this, but if I remove the grouping symbols, then it will either find the whole word the or just the T. So something to remember. I'm using another grouping exercise here, walk the dog. And I have a group here that specifies that I'm looking for the beginning of the line or a space at one end, at the beginning of the string. And then the other group, I'm looking for anything that is not from A through Z or occurs at the end of the line. So when I run this, it matches the space at the beginning of the, and then it matches also the space at the end of the, because it does not equal to a letter character. So just be inventive, mix and match these. If you need to find something, I'm going to clear the screen. Oh, well, that doesn't work. Control L will work in a better manner. I'm going to go full screen for this actually, so that I can show you what's going on here. So here, I'm looking for a or an. So this bracket expression is optional, and it's made optional by the question mark. That means 0 or 1. And I have this group right here that means either simple or easy, but this is also modified by 0 or 1, so it is not mandatory, and I have problem at the end of this. So when I run this, it will match a simple problem, an easy problem, or a problem. So it will match even though these are not present in a problem. So let's move on, and this one uses the asterisk, but there isn't much change because the asterisk means 0 or more. So still, it specifies that 0 is an acceptable amount for a match. But let me show you what happens when I replace that asterisk with a plus character here. Okay. All of a sudden, a problem is no longer matched because the plus symbol means 1 or more. So now this is mandatory. So this either has to be simple or easy for there to be a match. And here's an interesting lab. So the group consists of T or E or R, and now I'm looking for at most a group of 2 of these characters, or actually at the least a group of 2 of these characters, and at most a group of 3 of these characters. So you can see TRE has been matched as well as ET. Here's another example. Okay, now I am matching R, and then at most, at least a group of 2 E's, and at most a group of 3 E's. So you can see that this repetition statement only affects the character that it is closest to. It doesn't affect the R character in this lab here. I wanted to add a little bit more detail to show you that R is matched only at most once, and then the E is matched at least 2 times and at most 3 times. Now let's use a group and let's change it up a little bit. Now I'm specifying that the group consists of R and E. Now I'm looking for at least a group of one of these characters, this group of characters actually, or at most a group of two of this set of characters here, or the group of characters to be more accurate. So here we got re, we got re, we got re, and then we have re. So I just want you to practice with repetition. It's hard to understand if you don't practice with it. Now let's move on to messing around with phone numbers. That's very fun. I'm going to use this and I'm going to full screen. Okay, so see what that does. So here I am specifying a group of 3 word constituent characters. So either space or dash is optional, and then the same as in the beginning here, the same as right over here, and then a group of 4 word constituent characters, and that is the pattern. So all 3 of these lines match this pattern. And I have a documentation, little charts here. I like making charts. Okay, so let's try this next one. What does that do? So let's replay that. And let's take a look at what we have done here. So what's the difference? The difference is in the beginning of this command. So you see here, we're using the parentheses to indicate that this is a group. But here we want to match the literal parentheses. So we're using the backslash characters to escape the characters, the parentheses characters on either side here. So now this will only match the telephone number that had the area code in parentheses. So just to actually, let me do this one chunk at a time. So this block of code here, actually you don't need that. So this will match +1, and this is escape to indicate a literal plus here. And then we've got a dash or a space here indicated. And then we have this set of characters here. And this means that the parentheses are optional. So let me paste this in here and let me explain this step by step. Okay, so the +1 is matched and the plus is escaped, and we have either a space or a dash. And then we have this next grouping of characters here, and we're specifying with the question marks that the parentheses are optional, and then the rest of it is the same as before, where with the space or the dash optional, and then a group of 3 word constituent characters, and then a group of 4 word constituent characters, and so on. So yes, so this will be matched because it doesn't have parentheses, and then it has the +1 and then a space in front of it. Okay, let's discuss this one as well. So now the parentheses are optional. And now, okay, yeah, I figured this one out. Okay, so now the difference is this question mark is making everything before it optional. So just remember all of these symbols, the question mark and the asterisk and the plus symbol, all work on the characters that come before it. So everything that is coming before this is going to be optional. So now it will match the rest of the entries. The final thing I want to teach you is how to make a group non-matching. So the way you would do that, you would use a question mark and then a colon right afterward. And as you can see, this group right here, normally it would match something, but here it does not match anything at all. So now let's just have some fun with character classes. These are, so abbreviation for whole classes of characters. For example, this allnum is a synonym for all of these characters. So in some cases, these are faster to type than the alternative. This is the word constituent character that we used before. And then that's not allnum, so anything except for these characters here. Okay, and then matches the uppercase W matches a non-word constituent character. So that's about the same thing. So alpha, so that's alphanumeric characters, so lower and uppercase. So basically, if you use this, it's a lot easier to type apparently. Okay. And blank spaces, we haven't used those often. We have used spaces though. Control characters. Okay, I'm not seeing any. Okay, well, moving on. Not all of these will be useful to you initially. Digit characters. Graph. So graphical characters, allnum, and punctuation. So this is allnum and punctuation. Wow. So lowercase letters. Okay. Punctuation. We have used the space characters, the space symbolage here. Uppercase letters only. And finally, hexadecimal digits, if that's what you are doing. So finally, I'm going to clear the screen. Finally, I will have here some practical exercises. So I have updated, actually, the test file since I have written this episode. So I will be using this file rather than this one, actually. Let me get this off my screen. I'm going to use this command here. Okay. I'm going to go full screen. Let me clear the screen. And so here I'm using the regexp option to find these two patterns in this file right here, this configuration file. Okay, so very useful for that. Someone, oh, let me, oh wait, let me cat Okay, here are all of our uppercase characters. As you can see, someone messed up and they made Andy's name uppercase. They left the caps on key on, so ignore case will help me out with that. Okay, because it looks for capitalized and non-capitalized letters. So you can see here that most of our employees have 213 area codes, but one of our employees has a 415 area code. So if I wanted to find only that entry, I would do an invert match on the 213 area code that is so prevalent, and I have the entry I'm looking for. I found that to be interesting. Sometimes you want to use invert match to cut out the output that is clogging up the screen. I'm going to clear the screen actually now, and I'm going to use this series of commands to take the entries. Excuse me. And then put them into another file in alphabetical order. So I'm going to paste this to the screen actually. And of course I'm using semicolons to separate the disparate commands, and I'm using the first standard input symbol to send this to this file, but also to create this file, and then afterwards I'm only appending or adding to this file rather than overriding it. So let's run this, and let's cat the last argument, and now we have alphabetized our entries. And I thought this was a good idea. There's probably a more efficient way of doing that, but that was my way of doing that. So let's find everyone with a .edu email address. Okay, that's great. Let's look for Jones as a standalone word. Okay, I've already explained how the assemblage works, and the word reg exp option. So we found .edu email addresses, but we want to know how many there are. Okay, there's 4. So here's a funny one that I wrote. Echoing dog to file 1, echoing bear to file 2, echoing cat to file 3. And now I'm wondering, well, where did I put my cat files at? So the files without the cats are these. The files with the cats is this one. So again, if you wanted to limit the amount of matches, you can use the max count option. And I'm using the only matching to find how many .coms email addresses that we have here. And I'm using the word count to count the new lines. So it says 7, but I don't need that. Line numbers will actually not tell you what you want to see. It'll show you the matches, but the count option will count your matches for you. You gotta clear the screen again. Okay, and now I'm going to run this one, and I am creating file A, file B, and then forbidden .txt. Okay, so I'm going to exclude forbidden.txt from the search. Okay, and if I run this, I would run forbidden.txt. So let me just include file A. I wonder if I have to put a space there. Oh, I might have a syntax error. Dang it. Okay, so I use the curly brackets and the comma in between them, and so now I will just include the file A and file B and exclude forbidden.txt. So here I've created a whitelist, and here I've created a blacklist. And here's another way of looking for either this pattern or that pattern. And if we were looking for processes, we could use this type of bracket expression to cut out the process for the grep command itself from the output. Let me clear the screen. Here I wanted to list the prefixes for the telephone number. So I'm looking for a digit, I'm looking for a group of 3 digits, and then I'm looking for something that ends in dash. Well, I have to specify the file, don't I? Exit. There it is. Okay. Now I could use the word count to do this, but I could also just use the count option. That would be more efficient. And this works exactly the same way, but instead of digit, I'm just specifying 0 through 9. Again, if you want to match the literal dot, you'll have to escape that with the backslash. Okay, here is a lab. I tried to find a practical lab for back references. So imagine you wanted to know exactly when in this output the 11 showed up. So I'm looking for 11, and if it shows up again in this output, I'm going to match that again. So this will match the telephone numbers in this file. And now I'm using only matching to show just the phone numbers. So if you want to see the entire line, you would have to cut out that only matching option. Okay, I'm going to clear the screen. Okay, now I'm going to this lab I've run before. I just wanted to run it again to specify that you can group characters together and then just say either this pattern or that pattern. And that is the anchor that represents the beginning of the line. So here's another one. Becky or Samuel. Now, if I have forgotten Becky's last name, I only remember the first digit of it, I could put the dot right there and it will match the rest of that, because that specifies everything that everything else on the line coming after the capital Y. Okay. Actually, no, it does not. It matches the next character after Y. Now imagine I'm looking for the pattern keet, so I'm looking for one or more keet. I'm looking for Skeeter, and there he is. So again, just mess around with these patterns here. The more practice you have, the better off you're going to be. So I forgot how many L's that Camilla has in her last name, or her first name actually, as it turns out. So this character, the asterisk, means 0 or more. So I'm saying 0 or more of the next character, and then A. I wonder if that will work with period. I need more practice with dot. So yeah, any character. We could use that as well. But the next one, I think the last one here, so I'm using the question mark to specify 0 or 1 at symbol, because someone has put an entry in here without the at symbol, and I want to teach them that they need to put the at symbol in the email address for this to work. So that comes to the end of the labs. I hope you have enjoyed. Here's some review cheat sheet for you. I have my references here. I use the GNU.org page for grep, and I also use the Grimoire website as inspiration for this episode. So I hope to see you on the next one. The next one we're going to be working with sed to programmatically manipulate file content. So I hope to see you there. Thank you.